Over the last couple of years, and even more so in recent months, there seems to have been an increasing number of 3D printer users looking for higher quality, more reliable and more capable 3D printers. Personally, I'm also a little bored of being asked to review printers which are basically all the same. So if you're one of those people looking for a better machine, I'm going to help you decide today if the V-Core 3, a CoreXY high-speed extrusion frame kit by RatRig, is the machine you're looking for. This video was sponsored by RatRig, Duet 3D and 3D Prints, whom provided the printer and parts for review. More details at the end of the video. Also, the Vector 3D Workbench is live on Kickstarter now, so check the link in the description to find out more. Hello everyone and welcome back to the channel. Today I'm going to cover as much as I can to give you as comprehensive a picture as possible about what you can expect when you buy a V-Core 3. But I can't cover everything because this printer is configurable, which gives you a choice of all the things you want as well as the things that you don't. What I'm going to be focusing my review on is the default configuration. Now, I think it would be fair to say that I can be quite critical on my 3D printer reviews because I see it as my responsibility to find out all the stuff that the manufacturer doesn't tell you. So I just want to make it clear from the start that I think this printer is really rather good and can definitely recommend it. But of course, it's not perfect. So I'm going to tell you what makes it imperfect. We'll start with delivery and packaging. As of the time of writing, the RatRig website lists a lead time of 6 weeks for the V-Core 3, whether you have a custom or default configuration. However, reports from the community suggest that 8 to 10 weeks is probably more realistic, with some even taking longer. So some patience may be required. RatRig are working hard to bring down the lead times, but the more popular the printer gets, the greater the challenge is to meet the demand. When your packages do arrive, they are delivered in recyclable cardboard boxes. The extrusions are all wrapped in multiple layers of plastic, and lots of other components also have additional bubble wrap to keep them safe. They've made a good start on all of this, and all my parts were delivered safe, even though the box was a little damaged. However, it would be great to see a more sustainable implementation of the packaging with fewer single-use plastics in the future. With the parts safely delivered, it's time to get on with the assembly. As advertised, this is a kit, like a proper kit. If you find it intimidating to assemble IKEA furniture or an Ender 3, then this might not be for you. But if you think the assembly process is all part of the fun, like me, then this is going to be right up your street because there's somewhere around 30 hours of it to do. I did all the assembly and setup for my V-Core 3 across 12 live streams. So if you want some help with the build process, you can find a link to a playlist in the video description. One of the challenges I came up against during the early parts of the assembly is getting the frame square. While the manual does show you kind of what to do, it would be great if it also provides methods and strategies of how to actually get there. I think the use of jigs to avoid having to measure like precise dimensions in awkward places is something that would really help the experience. And the exclusion of washers from the assembly was a bit puzzling to me. Thankfully, the parts are organised. There are loads of little bags in this kit and they're each labelled with what they are, which is nice, but this is done with a pen that rubs off in the presence of oil. So for screws, it wasn't great. Fortunately, I've had reports that these have been replaced with stickers now, which is a pretty good example, I think, of how RatRig are reacting to customer feedback. The only time the assembly guide does tend to let go of your hand is when you get to the electronics. There is a wiring diagram for 2 of the control board options, and that's about it. I'd like to see a little more information here, personally, to help a little further, even if it's not kind of step by step. Again, you can check my live stream for some assistance if you need it. I use the Duet 3 board, obviously. My only significant issue with the assembly is the middle electronics panel. This panel divides the electronics at the back and there's other stuff in the front, and provides a mounting point for the control board, power supply and SSR. Unfortunately, this isn't included in the kit, and you can't buy it separately from RatRig either. They say that this panel is optional, but there's no really other design solution. So if there aren't other options available, isn't it just required? They're looking into ways to make this available in the future, but as of the time of writing, it's not available, so you would need to source your own. I used a piece of die-bond aluminium composite. I wouldn't necessarily recommend it, but it is an option if that's what you want to do. Taking a closer look at the individual components in the assembly, the extrusion pieces are all pretty good, cutting tolerances are good, there was no waste material left on the inside. The L plates are pretty well made with a good anodize. The corner brackets have a bit of a thick powder coat though, and I think that kind of impacted my ability to keep the frame square during that assembly. I also think the printed parts could do with a little more strength, as I had some of them crack during the assembly. The quality of the prints was okay apart from that, although I did have to drill out quite a few holes to get screws to fit, which is a combination of the printing tolerances I think, and some dimensions in the model which could be improved. All the parts are PETG, which is okay, but for a machine that has great potential for high temperatures, use of ABS would have been appreciated, especially for the Hotend and Extruder components close to the bed, or some other high temperature filament. With the printer now assembled, it's time to get on with the setup and configuration. As mentioned, I have the Duet 3 Mini 5 Plus and Mini 2 Plus expansion board to control my printer. But as there are multiple control board options, your experience will probably vary here. Instructions are included in the online guide for RatRig firmware, which is what drives the Duet 3 board, which they call a boilerplate configuration. It has most of what you'd want in there, but with spaces that you'd need to complete yourself or modify, such as like the build volume and PID values. It worked fine for me, but I do have some experience with RatRig firmware already. If it's your first time, it can be a little intimidating. On my control board, I think one of the MOSFETs has failed, as my Hotend fan no longer comes on with a specific temperature, it's just on all the time, which is a bit disappointing. The firmware in general is very powerful, as everything is configured at runtime through G-code commands, so there's no need to recompile the firmware each time you want to make a change. The downside of that is that when you troubleshoot, I personally find it a little bit of a daunting challenge to double check all of those configuration details. There are quite a few. If you do run into trouble at any point, you shouldn't feel alone though. A great community around a 3D printer can really make an enormous difference, and it's an invaluable resource, so don't forget about it. RatRig manage an official Facebook group, and there's an unofficial Discord channel with over 1,300 members now, which is more than double since I received my printer. They're growing pretty quick. There are lots of knowledgeable and helpful members in the Discord group, which I can highly recommend joining if you're interested in the RatRig 3D printers and other products. While some issues can be solved on the open communities from Facebook and Discord, RatRig can also be contacted by email for more direct response on support issues. While I'm not really a fan of Facebook groups, the combined community and support channels do basically cover everything you'd need. My guess is that they'll have a ticketed support system soon, as their user base is growing pretty rapidly and they'll need some way to manage it a little bit better, I think. If you're interested in designing your own modifications or just want more information on the parts, then you're in luck, because the V-Core 3 is open source. GitHub houses all of the files, and you can also find complete bills of materials on the project pages. A full CAD model from Onshape is also available, which you can download in a number of different formats. So good job there. On my V-Core 3, all of the day-to-day heavy lifting is handled by the Duet control board. While not as powerful as a dedicated single board computer like a Raspberry Pi, it runs the purpose-built Duet web control smoothly, and it's a great interface for handling prints. There's no display or controller on the printer itself, but this hasn't been an issue since I can just connect to the Duet web control on my phone and have full control that way. Even over Wi-Fi, it's fast to use compared to any of the old clicky, wheelie screens that you're used to. A panel duo would be a nice addition, but probably a little superfluous, and they are quite expensive. The box design of a CoreXY with the bed platform kind of in the middle, moving in Z, does make access to the bed a bit more challenging when it's not close, when it is close to Z0 rather. But I've not found this to impact me too much. Just be aware that the bed will be at head height if you have it on a workbench, and don't stick your hands in between the frame and the bed, like in here, when it's moving up. It's also just kind of bad luck that the part cooling fan blows smelly plastic smell right in your face when you're checking your prints, because the fan blows forwards. By the way, if you like in-depth reviews like this one you're watching right now, hit subscribe. Hit subscribe. Given the use of quality electronics, micro-stepping and stealth chop, I was expecting this machine to be really quiet. While the noise levels are quite good, it is a little louder than I was expecting. One advantage that cheaper, slower printers have is that they use plastic wheels on aluminium extrusion, so the rolling movement noise is really low. V-Core 3, however, uses linear rails, which are steel-on-steel contact, which provides a precise linear motion and a long lifetime, but at the cost of a bit of additional noise. The rails themselves are really good quality and have a great smooth motion all the way along the length, which is, of course, ideal for 3D printing. The other main noise generator on the printer is the fans. They don't seem to be particularly high quality and make quite a bit of noise when modulated with PWM. Overall printer vibration is reasonably low, and there are some included feet at the bottom of the printer to help reduce vibration into the worktop or work surface too. Noise doesn't really affect the performance though. That's mainly down to the Hotend and Extruder system. The Hotend and Extruder system on the RatRig uses standard components like the BMG and V6, which I have here, but the carriage on which they all sit is called EVA. Currently on version 2.3.0, this is a carriage platform for MGM rail-based printers, which is compatible with a number of different extruders and hotends. The system is not actually designed for the V-Core 3 or by RatRig, rather it's for any MGN rail-based printer. Like the main printer, it's also open source, so you can download and modify the parts if that's what you wish. This system is great because if you need to change extruder or hotend, it's really easy to just print the new parts and do it, rather than having to kind of totally change the whole carriage design or move to somebody else's design. And this is really helpful when it comes to troubleshooting, maintenance, and of course upgrades. I'm sure you'll agree it has a certain kind of style about it too, which looks pretty good. The configuration I have uses the E3D V6 hotend, and I think this is one of the major flaws in the component selection. The V6 has a peak flow rate of around 10 to 12 millimeters cubed per second, which sets fixed limits on how fast you can print, because once you go past that flow rate, it'll jam because the filament won't have melted by the time it gets to the nozzle. The rest of the machine is so capable that it can easily print faster than the V6 will allow. So my number one recommendation for anyone buying this machine is to go for a hotend which has the highest flow rate you can afford. The V6 isn't bad, it prints great actually, the quality is fine. It's just outdated and there are better, faster options available for a premium printer like this one that just loves to print fast. The Bondtech BMG is a bit of a classic too at this point from back in 2017. It feels like it's been around forever, but if it ain't broke, don't fix it. And it hasn't caused me any problems on this machine. In the V-Core 3, this is paired with a 0.9 degree stepper motor from LDO Motors, which, despite being a pancake motor, can produce a lot of torque. You can also use a BMG M, which is the Mosquito version, with the addition of a small printable adapter too, which is pretty clever. After melting all that plastic though, you need somewhere to put it. Arguably one of the standout headline features of the V-Core 3 is the Kinematic Bed. So called because of the use of a kinematic coupling system to mount the bed to the rest of the printer. Amongst other things, that means there's an allowance for the thermal expansion to prevent any unwanted distortion, which would happen if you kind of rigidly mounted it. The bed also utilises 3 independent Z motors to level the bed, or should I say tram the bed, to a kind of true level / tram. It doesn't just look cool though, it actually works really well too, and it doesn't really take too long to run, so you can do it at the start of each print to ensure the bed is obviously level. The Z-axis as a whole is just really well done. The motion is constrained using the Z linear rails, and the lead screws just take care of the height. While it would probably be ideal to get the lead screws perfectly aligned to everything, the Z wobble that I've incurred from not being quite right is actually not too bad. So it's a pretty good design. I'm impressed. The printing side of the bed is provided in the kit and is made by 3D Prima / Prima Creator. It's a kit that includes a magnetic sheet and powder-coated PEI spring steel surface. The spring steel is quite thin, the magnet is actually not that strong, and the sheet is a little bit smaller than the bed, though it still allows for the 300mm cube, obviously. Large prints on this bed though that have a tendency to warp will pull the edge up off the bed because it's just not really strong enough to hold down large warpy prints, but smaller things are fine. The PEI is only single-sided, so no opportunity to flip it over if you do any serious damage or for longevity. And because the spring steel is smaller than the bed, it can be a bit of a pain to align it to the bed, and if you don't position it quite right, the bed probe will miss the surface and mess with your leveling, so that can just be a little bit of a pain. A slightly larger sheet or some alignment method would be really very much appreciated here. After a handful of prints, I know where it needs to sit, but it does take a couple of times just to get it into a position where I'm happy to leave it to know that it's going to be fine. The print surface sticks really well to prints, but annoyingly doesn't release them as easy as you'd like in comparison to some other surfaces, such as the Prusa Texture PEI and Filaprint by Filafart. I found that ABS Plus in particular is really clingy, so be a little bit careful with that one. As I mentioned, I am quite picky and I am being quite fussy here. None of these issues are deal breakers, but as I mentioned, I'm going to tell you as much as possible so you know what to expect when you buy one. It is, at the end of the day, still a really good, flexible PEI print surface that does work rather well. The Kinematic Bed is not the only highlight though, there's also CoreXY to look at. While CoreXY is really nothing new at this point, it does still attract a certain amount of interest due to its unique belt path and ability to limit gantry mass by keeping the motors completely static. The layout on the V-Core 3 is perfect. The belt paths are straight, there's great wraparound on the pulleys for maximum grip, and the 9mm belts reduce kind of stretch compared to their 6mm equivalents. They aren't genuine Gates belts, but they do seem to be of pretty good quality and I've not had any problems. The motors for all three motion axes are statically mounted and are all provided by LDI Motors, quite well known in the 3D printing industry for providing quite great quality and high performance components, so good choice. The quality of the idlers is not quite as good though. While doing a bit of fiddling and maintenance testing, I did notice that one of the bearings that doesn't actually fit properly, like tightly into the idler, and there's definitely the occasional squeak that sounds like it could be from a dry bearing, but since the bearings are sealed, you can cover them with as much oil as you want. Very little is really going to be getting into the bearing casing. Kinematics are not the only important thing though. As always, safety comes first. The bed used on this printer is powered by mains AC, and it's a kit that does require you to deal with mains wiring too, so be careful. The adhesive-backed silicone heater, which obviously on the bottom, is made by Kinovo and includes a thermal fuse for 157 degrees Celsius and secures to a very nicely made cast aluminium that includes a mounting point for an earth wire. The wiring management from the bed is not ideal though. I think it's okay because the bed doesn't really move that much compared to the X and Y, but personally I'd still prefer some additional management to prevent any risk of fatigue at the bending points just from, repeated bending over time. When wiring yours, I just suggest that you make sure you have your bed right up at the top to make sure you allow sufficient cable length, because otherwise obviously you'll stretch them when you do go there. The wire management for the gantry motion is a little bit non-existent though. I think there should be some cable sleeve and nylon filament or spring steel included to allow you to safely manage those wires, because otherwise they can just get a little bit untidy. The power supply is the WeHo LRS 250 24 volt. It does have overload, over voltage and over temperature protection and is rated for operation of up to 70 degrees C, although personally I'd still recommend keeping it as cool as possible. The mains powered bed is switched by a C-Lin 40 amp SSR. C-Lin is a Chinese manufacturer for industrial control components, and this is what Kinovo use, and they've been supplying heaters and stuff like this for quite a little while now, so I'm not too worried. I've not tested it to its limits, but it's not caused any problems for me. While you are left to your own devices to set up the wiring and keep it organized, I have some clips available on GitHub. You can use those and they'll help you. Fortunately, the panel design does make everything quite easy to do. Mine turned out disgustingly tidy and with very little effort and only a modicum of planning, so I'm sure you'll manage. What really matters though, if you're buying a 3D printer, is the ability to print. From my experience, slicing profiles are the most important part of 3D printing. You can get good prints off a terrible printer if you have a well-tuned profile. Unfortunately, if you have a bad profile, you can get bad prints off of a great printer. At the time of writing, that RatRig V-Core 3 has no pre-configured slicing profiles. I can only assume that the reason for this is that there are so many possible configurations that it would be just really impractical for a small company to develop all of those profiles. I think it would be nice to provide some suggestions for starting points for retraction, speeds and flow rates, etc. for the supported extruders and hot ends, and perhaps some start G-code suggestions too. This is what my first prints of the V-Core 3 looked like. Not particularly great, but not total rubbish. This was done on the live stream though with absolutely no tuning. To do the tuning, I ran a number of tests / calibration prints for flow rate, XY calibration distance, first layer consistency, retraction, skew, and all that kind of stuff. Once I was happy with the slicing profile and firmware configuration that kind of went hand in hand, I started printing a greater variety of parts. Unfortunately, I kept getting jamming in the nozzle. It was an absolute nightmare as I went through basically everything that I could think of just to try and get something working. I even ended up to rebuilding the V6 just in case. I contacted RatRig for some support as they use this exact configuration quite a lot, so they know it works. They put me in touch with some of their dev team to try and work out the issue. So long story short, once I heated my nozzle in the oven and used a small blowtorch, like a kitchen blowtorch, to really heat it up, it worked much better and all the jamming stopped. I can only think that there must have been a piece of non-melting material like brass or something that kept getting stuck in the nozzle, and an acupuncture needle only temporarily dislodged it. So I'm glad that's sorted and everything now much better. So now that things were performing much more consistently, the print quality really started to improve. I will point out, as you've likely already noticed, there is a fair amount of ghosting. I've not tuned or enabled dynamic acceleration in RepRap firmware, so the high jerk values I'm using result in quite a lot of ghosting in one axis. It did reach a point that the printing consistency got so good that I just immediately got stuck into printing loads of stuff, a whole load of ABS parts that have all come out really looking very good. So I'll let you guess in the comments what those bits are for. While this printer can definitely print fast, the default configuration with the V6 really isn't up to the task. So get subscribed and I'll be having a go with a high flow rate hot end after this review is finished. Now you know most of what there is to know about the V-Core 3. Is it worth it? Wholeheartedly, yes. I find it difficult sometimes to put into words exactly what my opinions are about a printer. I like to refer to objective measurements and tests which can be kind of ordered in a logical outcome, which I can then refer my opinion to that. But sometimes there just feels like there's a little bit more to it, and this is one of those times. Getting started, set up and configured with the V-Core 3 takes a while, and at times it felt like a bit of a struggle, especially with all the tuning and calibration. But because the design is great, the rewards for your efforts are great too, and I've really enjoyed the process. As I mentioned at the start, there are many users now looking for high quality, more reliable and more capable printers, and this is exactly that. Within just a few weeks that I've had this printer, it's already like a set and forget printer. I happily just start prints from the other room, knowing that they'll succeed. Not even a second thought. One thing I didn't expect from this kit though is how much it would reignite my enjoyment of printing and tinkering. I've looked at so many average and boring and samey printers over the last year or so that 3D printing itself just started to feel boring. The V-Core 3 was such a breath of fresh air. I'm already planning more that I want to do with it. I want to help make it better. I want to make sure that everyone else is enjoying the build process and using it. It's just so good. And it's just so fun to be involved with. Of course, this is in no small part thanks to the great community that surrounds the project. If it wasn't already clear, I can definitely recommend this printer. Not as your first though, unless you have electronics and assembly experience previously. If you'd like to buy a V-Core 3, you can use the voucher code in the description to get €25 off, and this gives me a small amount of kickback too, which I would very much appreciate. In the interest of fairness and openness though, it's only right, of course, that I let you know my biases. When looking for upcoming review content, I contacted RatRig about a potential review unit. I found their website online and their products looked interesting, hence why I contacted them. They suggested the V-Core 3, but at the time it was still in development. Upon release though, after the pre-orders were shipped, they sent this kit for purposes of doing the live streams and the review, which you will have seen now. The Duet control board and mini expansion was provided upon request by Duet 3D, and the Bondtech extruder was kindly provided upon request by 3D Prints. So that's it from me today. That's the V-Core 3. Hopefully this has been useful for anyone either been looking at this printer specifically or just looking for more high-end, very capable 3D printers. Thank you very much for watching, and I'll see you in the next one.